Welcome to the unit about lactones, an important group of flavor molecules. Lactones can be defined as cyclic esters of gamma and delta hydroxy acids with a chain length from C8 to C12, which are important for the flavor industry. The most important one is gamma-decalactone. It has an oily, peachy, extraordinarily tenacious odor and a very powerful, creamy, fruity taste. It is peach-like in concentrations below 5 ppm. Gamma-decalactone is used in fruit and dairy flavors as well as in numerous beverages. Synthetic gamma-decalactone is produced at about 500 tons per year, while the market for the natural product is about 10 tons per year. So let's have a look at the fermentation process. Already in 1963, the group of Okui observed that some Candida species metabolized ricinoleic acid and formed gamma-decalactone from 4-hydroxydecanoic acid, an intermediate of beta-oxidation. Later also other yeasts like Sporobolomyces odorus, Pichia guillermondii and some species of Sporidiobolus were identified to produce gamma-decalactone. But the only organism which is used commercially is the yeast Yarovia lipolytica, which has been reclassified in 2016 to Yarovia deformans. This is a lipophilic yeast which has been obtained with GRAS status by the FDA. GRAS means that this organism is generally recognized as safe. It can hydrolyze castor oil, which you may know as a laxative, with its own extracellular lipase. The main fatty acid in castor oil, with about 90%, is ricinoleic acid. Ricinoleic acid is degraded by 4 rounds of beta-oxidation to 6-hydroxydodecanoic acid. At this stage, a reductase eliminates the double bond so that 6-hydroxydodecanoic acid is obtained. The beta-oxidation stops after one more step on the stage of 4-hydroxydecanoic acid. At low pH values, this hydroxy acid cyclicizes spontaneously to gamma-decalactone. Yarovia lipolytica possesses a family of 6 acyl-CoA oxidases, which are AOX1 to AOX6, which are encoded by POX1 to POX6. The first enzyme of this pathway is generally considered as the limiting step in the catalysis. So a number of groups worked on mutants for these enzymes to improve the yield of gamma-decalactone. Generally, castor oil is fed to the production culture to obtain the highest concentration of the product. In addition, the right concentration of dissolved oxygen is important to obtain gamma-decalactone as the main product and to avoid the formation of byproducts like 3-hydroxy-gamma-decalactone, 2-decenolate and 3-decenolate. At the end of a fermentation, a product concentration of more than 12 grams per liter in 2.5 days was reached with a not genetically engineered strain. After we had a closer look to gamma-decalactone, I would like to discuss a number of other lactones which are of interest. In the range of gamma-lactones, these are the gamma-dodecalactone, which has a peach, butter, and fatty odor. Gamma-dodecalactone can be obtained analogous to gamma-decalactone using 10-hydroxystearic acid instead of ricinoleic acid. 10-hydroxystearic acid can be produced by hydroxylation of oleic acid by an oleate hydratase. The oleate hydratase gene of Stenotrophomonas maltophylla has been cloned in E. coli and a product concentration of over 40 grams per liter was obtained. In a patent from Cardillo et al. In 1990, they disclosed the process to produce 1 gram per liter of gamma-octalactone from 10 grams of coconut oil with Cladosporium suaveolens. Gamma-octalactone has a sweet, herbaceous, coconut-like odor. After discussing the gamma-lactones, we now look at the delta-lactones. Delta-decalactone possess a very powerful and tenacious, sweet, creamy, nut-like odor with a heavy, fruity undertone. The taste is creamy, sweet, coconut, peach milk-like at concentrations below 2 ppm. A process for the production of delta-decalactone and also delta-dodecalactone was developed by van der Schaft and his group at PFW in the 1990s. They used the unsaturated lactones in the Massoya bark oil as substrate and hydrated them with a reductase present in baker's yeast. Recently, a Korean group published an alternative process for delta-decalactone. They hydroxylated linoleic acid with a linoleate 13 hydratase from Lactobacillus acidophilus and obtained 13-hydroxy-octadecenoic acid as intermediate, which was then metabolized by Yarovia lipolytica to delta-decalactone. All of these natural lactones discussed before are available on the market and sold nowadays by several companies, but the volumes are significantly smaller compared to that of gamma-decalactone. Thank you for attending this lecture about the lactones.